there it's a B day. All right, take a look at the first ratio table. And look at the values for X and Y. I'm not even telling you in the data table or the ratio table what we're comparing. I'm just giving it a letter. Everything on the left we're going to call the X values, and everything on the Y, everything on the right side we're calling Y values. So it's not pens or pencils, boys or girls at this point. Don't let it bog you down. Left and right. When you go from left to right, what are you multiplying by? Because you've got to get multiplicative structure in your head before you can start creating equations. Alexa, does everybody agree? Times 4. As long as the ratios are equivalent, which they are, that times 4 factor should work for everything. Put them in for every single one. I want you to do it exactly the way that I show you to do it. So we say that the multiplicative structure for this ratio table is times 4. Now, is it okay? Are you comfortable with me using the dot? I want to use the dot more and more so it doesn't get confused for the variable x. Probably should have used it here in the table itself, but I'll leave it there for now. Before you can create an equation, you have to have multiplicative structure in your head. You'll also see, which wasn't really articulated well in lesson 13, that sometimes the multiplicative structure is really the divisional structure. I'll get to it. You'll see. All right, ready? As dumb as this is going to seem, do this with me. Do you agree 1 times 4 is 4? Do you agree that 2 times 4 is 8? Do you agree that 3 times 4 is 12?
Yes.
Do you agree 4 times 4 is 16?
Yes.
Do you agree that 5 times 4 is 20?
Yes.
Ready? Do you agree that any value that I give you for x, times 4 will equal the value for y?
Yes.
You good with that?
Yes.
You've just created an equation. You don't even know it. All I told you is, watch what I did. I said, any value for x times what?
4.
4 will equal the value for equation done. That's all that is. What kind of confused you yesterday, and I'm going to get to, you tell me, is this equation the same as that equation?
Yes.
Will it work in both cases? How many say yes? Raise your hand. Okay. See, I can take either part. We'll make believe that the equal signs like train tracks. We got the left side of the tracks here, the right side of the tracks. I could take the expression, this x times 4 here, which was on the left, and flip-flop it with the y on the right. And I would be fine. It doesn't matter what comes first. It's still y equals x times 4, or look, y on this side equals x times 4. It's still the same equation. The way that you prove that an equation is correct is by using, what's the S word I used yesterday? Do you remember? Say it. I'm going to substitute any pair of ratios in the table. Give me a set. Will, give me a set. All right, I'm going to use the set 3 and 12. I'm going to get my red pen. Not that it matters. I could use a finger, but that's all right. Okay. What'd you say, Will? All right, this one, 3 and 12, right? Okay, let's prove that it works. You take the equation we created here. I'm going to circle it. And all I'm going to do is rewrite it without substituting just yet. Now I'm going to substitute. Sebastian, help me out. What value in the circle ratio, which of those two values, 3 or 12, is the x value? Look again. Are you sure?
Oh, 4. No.
Look, these are my, this is going to get really busy up here. These are my x values, these are my y values. Of the one that Will gave us, which is the x value? You got it. I'm going to substitute in. Where I see my x, I'm going to replace it or substitute it with the 3. This times 4 never changes. That's your multiplicative structure. That never changes. Not right now. Evaluate it. What's 3 times 4? Is that the other half of the ratio? Now you know that this equation is correct. That's how you prove any equation is correct. If it works, it will work when you substitute the value for one of the variables. Well, either one of these are correct. Okay? The only reason why I have all 3 lines here is technically to take it to completion. You do 12 equals 12 and you're done, but you don't have to use this. That confuses you when you substitute. But say to yourself, is 3 times 4 12? And if the answer is yes, you know your equation's fine. Okay, I have to erase this hodgepodge up here. I don't know how busy yours looks, but mine is not workable right now. So I've got to erase that to go to the next thing. When we went from x to y, we did what? We multiplied by a factor of 4. What if I go in the opposite direction? If I go from y to the x, what am I doing now? By how much? Does everybody agree? We're dividing by 4. We go from y to x, or we go from right to left. You're dividing by 4. Yes? Does it hold true for every single value? Will it work? All right. You may not have room to put this in, but I do now. So I'm going to put it in. And I'm going to go through that same basic routine with you because I think it's important for you to get used to, I guess, repetition in this case. Is 4 divided by 4 1? Agree? I can't hear you.
Yes.
Is 8 divided by 4 2?
Yes.
Is 12 divided by 4 3?
Yes.
16 divided by 4 4?
Yes.
20 divided by 4 5?
Yes.
Is any value that I give you for y divided by 4 going to equal the x?
Yes.
Ready? Any value that I give you for y divided by 4 will equal, that's my equation for x. One goes one way when you did it in the first one. One goes the other way. Okay, now a little Q&A. You ready? Is this equation the same as that equation? How many say yes? Oh, sorry. I made a mistake. And you would be right. I meant to put y here. My fault. What about now?
Yes.
Raise your hand if that is still good. Anybody disagree? What about this? How many say yes, that'll work also? How many say no? All right, you get it. You get it. See, I could take what's on the left side of the train tracks or equal side and flip it with what's on the right side, but I cannot change the order of the variable, the division symbol, and that 4. That I've got to keep intact. But I could flip it. I could put it on this side or I could put it on this side. What I can't do is flip it. And I cannot do that with subtraction either. I can technically do it back in this equation because did you learn in elementary school that 4 times 5 is the same as 5 times 4? You can switch the order. Does anybody know what property of math that is? When you can, order doesn't matter, it's called the commutative of, you got the key part. What did you say, commutative of? They might have referred to it as that. Commutative, we say it a little different. Commutative property of, oh man, starts with the same letter,
The commutative property of
multiplication, and it'll work for addition also. Can't do it with subtraction, can't do it with division.
So it has to be.
Yes, because you saw how I worked it out when I said it out loud to you. Any value that I gave you for y divided by 4 equals the x. So that's kind of the reason why I say it out loud, is because when I say it out loud to you, it's forcing you to write it in this order. Okay? So that helps too when you say it out loud. Sometimes it helps you to see through. Okay, I'm going to take, not that it matters, but I'll use this equation just to prove that it works. I'm going to rewrite it. Everybody do that. Y divided by 4 equals x. How do we prove it? Snake.
Prove it by just the equation.
All right, I already have the equation written. Now what?
Now you're going to say x and y.
Yeah, yes. Pick any set of values that you'd like from the data table. What do you want? Your choice. Okay. Now you just got to be careful when you make that substitution that you know what's what. I hate scrolling back and forth, but I'll try to make it work. I'll scroll maybe just as high as I need. All right. All right, Nath. In that 4 and 16, which one of those two values is the y? I am going to substitute 16 instead of the y. Divided by 4 never changes. And what's 16 divided by 4? It works. It works. Got 16 we put in. It's like an input. Have you done input-output tables in elementary school? We used to do those a lot when I was in elementary school, called input-output tables. They got away from it with I'm not going to say even Common Core. It's been gone for a while, but man, those used to help me a lot. Input-output. We input 16, we got out. We input 16, output is 4, but what am I talking about? I thought it worked when I was in elementary school. All right, now comes kind of a tricky part, a little tricky. If you haven't done it so far, you should have an equation circled here for x and an equation for y. One's for y and one's for x. Have you circled it? Circle it, because one of those two has to be used to solve. Technically, this is like a little short mini word problem without a storyline to it. It says you got to choose an equation. That's one of these two. One of them will work, one of them is garbage for now. Choose an equation and solve the following. They tell me that x is 44. That's my input. They want to know why. So let me ask you this. What am I trying to solve for? Am I solving for x or am I solving for y? Right.
You're solving for y.
I'm solving for y. Therefore, I need the equation for y. Which equation is for y? The first one or the second one? Be careful. Which one? This is x equals. I don't want x equals. I want to find what y is equal to. So therefore, it's the first one. So I'm going to put it in. That's the first thing I do. Okay, I know my equation is the one for y. And honestly, this is totally up to you, but I don't care which one of this you use. If this makes more sense to you to put the y on the left, as long as the other expression is x times 4, you do what works best for you, but whatever you choose, it has to be the y equals. This is the y equals, and this is the y equals. That's like the hardest part, is choosing which equation to use. Now we got to do, what's the S word? And they give us what x is. Which one do you want to use? How many of you like the one on the left better? How many like the one on the right better? I'll do it both ways. X is 44. Wherever I see an x, make believe you're replacing it with the number 44. There it is both ways. Doesn't matter. You're still going to get the same answer because no matter what, you have to multiply 44 times 4 to get the answer. So do that. What do you get? Some of you already have done it. 44 times 4. How many of you can do it in your head? Not that I'm asking you to. I know Ryan Wetter can. Mental math. Gemini Quinto, what'd you get? How many of you got 176? 176 equals the value for y, or y equals 176. Now, why do equations come in handy? Think about what you just did. What was your x? What was your x again in this problem? What was it? It was 44. Technically, if I scroll up, 44 was your x, and then what was your output for y? 44 was my x. When you multiply it times 4, what'd you get? 44 times 4, what did you get?
Oh.
You've made an equivalent ratio. This 44 to 176 is a ratio that's equivalent to all the ones above it with the value of 1 to 4. But look at the advantage. The reason why I say, oh, why do we need this in math? Why is this important? Because if you know equations, and some of you will be like really good with equations, it's the easiest way to get equivalent ratios without having to do tape diagrams, without having to do TRF, without doing an equivalency ratio table. Because look, do you really want to do all of the numbers in between 44 to 5 to get to this? 6 to 24, 7 to 28, 8 to 32. Until you get to 44, your table would be 5 pages long. If you know how to form the equation, you can find the equivalent ratio for anything. To form an equation, all you really need to know is multiplicative structure. And you got to practice it. It takes practice. Up the page, and the only difference between number 2 and number 1 is you have to find the missing values in the chart. Start with that. Watch, bud. You'll notice there's only one row where they give me both values for the ratio. What are those two numbers? There's only, when you look at it, there's a missing piece in every single row except for which one? Nick. There's a piece missing here, there's a piece missing here, there's a piece missing here, there's a piece missing here. There's nothing missing here though, is there? 2 to 16 is a complete ratio, right? What's the multiplicative structure of 2 to 16? All right, you're done. Believe it or not, you're done. Times 8. Now, let's do it. Nick, let's do it. Let's do it. Once you establish that multiplicative structure, that times 8 is good for every single row. Only place where it might get a little tricky is when the first value the first value is missing. But let's do it. 1 times 8 is done. 2 to 16 is the given. Ready? What number times 8 makes 24? Good. 4 times 8. What number times 8 makes 40? Done. I have to, if we do this, I always have to give you at least one set of ratios that's complete. Otherwise, you can't figure it out. And then you build off of that. Get it? All right, let's see if everything else falls into place. Multiplicative structure is what? Somebody else. Madison. Times 8. Soph. The equation? Okay, so who has an equation for y? I just want to see who has it, and I'll call on somebody. All right, so if it's an equation for y, it's got to be y equals something, or something equaling y. So what do you have? So if you. Let's see if it works, because we got to prove it or disprove it. Write down the original. Doesn't matter what order you have it. All right, I need somebody to pick out an x value. Addison. Okay, 4 it is. I'll color code it so you can see it. There it is once you substitute it in. See, all I did was wherever there was a y, I replaced it with a 4, or substituted with a 4. All right, evaluate it. Either one. 4 times 8 is what, everybody? 4 times 8 is what, everybody? All of a sudden, we're quiet. 32. It works. Equation is good. How many of you got it right? All right, go in the opposite direction. Well, equation for x. If you kind of know the secret, you could take the shortcut. But if you don't know the shortcut, start by going in the opposite direction. If you're going from y to x, dividing or multiplying? Dividing. By how much, Carly? Even though I put it up there. Divide by 8. That number is not going to change. Either it's times 8 going this way, or divided by 8 going this way. All right, no more moonwalking for me. I'll let my fingers do the walking. Have you seen the moonwalking fingers? All right, watch. I know, this is not going to get blocked, unfortunately. Ready? Moonwalking fingers. Ready? The fingers work better than the feet. Ready? Here we go. And here we go. There we go. Woo! Like that? I have a whole breakdancing routine with fingers. Dumb stuff that we do. Want to see it one more time?
Yeah.
All right, you get a second showing. Here it goes. Here we go. Ready? Here we go. You got a picture, like, think of like a Michael Jackson song in your head? All right. Din, 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 din. She was more like a beauty queen from... There we go. Oh, God. That's on the blog. Anyway, back to math. From a movie scene.
I want to go to the blog just for that.
Here we go. Who's got the equation for x? I need x equals or something equaling x. Order matters, though, so make sure. And you know there's going to be a y on this side. Ava. Let's see if it works. Try to make my y's a little bit better. Okay. I'm going to rewrite it here to see if the proof will work. Ave, give me a value for y from the data table. All right, we'll start basic. We'll use the first one. 8 is my substitution. All right, what's 8 divided by 8? And sure enough, when you use 8 as your y, x is your output, the equation is good. All right, let's do a fist of 5 check. Where are you at with fingers? How many gained at least one? Raise your hand if you gained at least one finger. Some of you are already at 5 fingers, which is good. Is it starting to jive a little bit more with you?
Yeah.
Because it's going to get better if you practice it. You just need to practice it. Where are we lost, though? Where? Where's the disconnect? All right, I'll sit down with you. I will. Christian. Yeah, because you weren't here yesterday, so that's not bad. All right, let's continue. I want to do one more together, and then those of you that are kind of ready to go on your own, I'll kind of give you that freedom, but I want to do one more. What? Okay, let's go to the next page. I do want to do one of these because now, and you'll see this is in lesson 13, and they get to this type of ratio table before we had enough practice where the numbers are going from big to small now. And they make that leap in lesson 13 before we've had enough time to practice. Going from, what? Oh, what? Oh, we still have to do this. Well, why don't you just do it? Do it. Give me an answer. I'll walk through. I do want to check it and see. If it feels like we're okay and most of you are getting it, I'll go on to the next page. You've got to pick an equation for what, though? Let me get you started. What equation do you need to use? The x equals or the y equals? Nicole, which one? Right, you need the x equals equation because they're giving you the y. Okay, take it from there, and I will come around and check.